In this video, we are going to have a look at some examples at calculating average power using work done. So this first example, we have a car of 2,000 kilograms travelling on a straight horizontal road, and we're told it accelerates from 10 metres per second to 20 metres per second in 8 seconds. Part A wants us to find the work done by the driving force. Now we know that the increase in kinetic energy will be equal to the work done by the engine. So to work out our increase in kinetic energy, we're going to find a half mv squared minus a half mu squared, where v is the final velocity and u is the initial velocity. So to start off, we have a half multiplied by our mass, which is 2,000, multiplied by our final velocity, which is 20. And then we're going to subtract our half times 2,000 times 10 squared. That's our initial velocity. And if we pop that into our calculators, this is going to give us a work done of 300,000 joules or 300 kilojoules. Now in part B, we're asked to find the average power generated by the engine. Now to do this, we're going to use the formula average power is equal to work done divided by time taken. So now we can use our value from part A and the 8 seconds that was given to us in the question. So we're going to have that our average power is equal to the 300,000 divided by the 8 seconds. And this is going to give us an answer of 37,500 watts, or we could write this as 37.5 kilowatts. This next example is quite similar. So this time we've got a model train, another straight track, and we've got that it accelerates from 2 metres per second to 8 metres per second in 3 seconds. And again, we're trying to find the average power. So we're going to use the same two formulas that we did in the previous example. So let's start with our increase in kinetic energy. So once again, we're going to do the final kinetic energy, subtract the initial kinetic energy. Now, one thing we can notice about the mass in this question is that it's given in grams. So we do need to convert this to kilograms when we're using it in our formula. So we're actually going to have a mass of 0.2. Our final velocity was 8. So we've got 8 squared. And then we're going to do the same, but with the initial velocity of 2. So when we pop this into our calculator, we're going to get a work done of 6 joules. Now we're going to use our power formula. So we're going to have the average power is equal to the work done, which was 6, divided by the time taken, which was 3. And this is going to give us an average power of 2 watts. In this final question, we are now looking at a sloped problem. So we have a car on an inclined hill. We've got an initial speed of 10 metres per second and a final speed of 60 metres per second, taking 60 seconds. We're still finding the average power generated, but we're going to need to start by using our Suvart equations to work out the acceleration of the vehicle. We're going to use v equals u plus at. We've got it from the question, v is equal to 12, u is equal to 10, and t is equal to 60. So substituting these in, we can rearrange this to get a is equal to 1 over 30. Next, we're going to use f equals ma to set up an equation for the slope. Now in this case, our force is referring to the driving force. So we can use the formula for driving force is equal to power divided by speed. So I'm going to draw a quick diagram just to see exactly what forces I've got acting on my vehicle. So I've got the driving force going up the slope, and down the slope I've got the resolved weight. So that's going to be 1600 G sine 10. So let's set up my F equals ma using these forces. So I'm able to use my A from my original calculation, which is 1 over 30. Now what I'm going to do is I'm going to replace my driving force with my power divided by speed. So I know that my speed is going to be my average speed. So we've got the initial, we've got the final, over 60 seconds. So the average speed is going to be 11. I'm going to use g is equal to 10 in this question. So I'm just going to replace that with 10. And then I can rearrange this equation to find out what my power is. So if I rearrange this equation, I'm going to get 31,148.7 watts, or I could write this as 31.1 kilowatts.